Experiment 12, generation of gases. What you're going to experience here is generating hydrogen gas and how we test for that, generating carbon dioxide gas, how we test for that, and generating oxygen gas and how we test for that. So what I have in the test tube rack on the right-hand side are two test tubes with approximately 5 milliliters of 1 molar hydrochloric acid solution. In the left-hand side of the test tube rack, I have approximately 5 milliliters of 10% hydrogen peroxide solution. So in the first test tube, I'm going to add some sodium carbonate, Na2CO3. And we know carbonates, when they react with acids, can decompose and generate a gas. So let's see what happens. So I'm going to use a small portion of sodium carbonate added to the hydrochloric acid. I'm just going to move this test tube out of the way for a moment. I'm going to add, see what happens. Notice we have a lot of gas being generated. I want to see what's going to happen to that gas. I'm going to use a flame test, and I'm going to insert a burning splint. So therefore, the gas that I have in there is extinguishing a flame. So that verifies that we have carbon dioxide gas as the gas that was present in that test tube. You can see that it is still reacting as I bring it a little bit closer. So as long as that excess reagent, the hydrochloric acid, is present with the limiting reagent, the sodium carbonate, that sodium carbonate will continue to react and decompose to make a salt that's aqueous, carbon dioxide gas, and some water, because that's a true neutralization reaction. All right, so with the second test tube, now that I have the hydrochloric acid, I'm going to take a piece of magnesium ribbon. So magnesium metal is a shiny metal, and it's from group 2A. It's an active metal. So I bent it slightly so that way it can fit into the test tube and drop down. And if you notice, we're starting to see some bubbling there. And so therefore, there's a gas being produced. So you can see the gas. Oh, and it's getting really warm on that test tube, unlike the other one. So I'm going to try to collect some of that gas. So here we have essentially the same outcome as the previous test tube, but it's a different gas because here we have a single replacement reaction occurring between the free state magnesium and the hydrochloric acid. And so we know from the activity series that magnesium is more active than hydrogen, so we can displace that hydrogen and make hydrogen gas. And therefore, we make an aqueous salt, magnesium chloride. So I'm going to test this gas. Whoa. Now look at the inside of that test tube. See how it looks all kind of foggy? Because we just made some water. We combusted that hydrogen gas in the presence of oxygen. And notice if I put this in there, the hydrogen gas itself can't support a flame, but in the presence of oxygen, right here at the opening of this test tube, I was able to generate the combustion process. And so notice, look at all the water vapor that's condensed there, which made a lot of water after reacting that hydrogen. So hydrogen gas can be tested with a flame. Hydrogen in the presence of oxygen will burn, combust, which is what you saw in that inverted test tube when I brought the flame near the opening. And hydrogen gas in this test tube extinguished the burning flame because hydrogen itself can't support a flame. It needs oxygen to do that. Another gas is one that can be evolved by hydrogen peroxide. And hydrogen peroxide is what many people use to alleviate the infections that could arise from minor cuts. So I'm going to use a little bit of manganese 4 oxide. Manganese 4 oxide is not a reactant here. It actually is a catalyst. It's going to help the reaction for the decomposition of hydrogen peroxide to occur, but will not itself be consumed in the reaction. I could recover it all if I wanted to. So I'm going to add that in. And so I see that this is bubbling vigorously. So I can see that bubbling away. And that's getting warm. So we have evidence of a chemical reaction there. I'm going to let that gas generate for a little bit. I'm going to get a burning splint going, but I'm going to let it turn red. I'm going to insert that glowing splint. Oh, look what happened. Inserting a glowing splint, and it reignites. The only gas that can cause reignition of a glowing splint is oxygen gas. So we've gone through 3 gas generations. We generated carbon dioxide gas when we reacted the sodium carbonate with the hydrochloric acid in a neutralization reaction. We generated hydrogen gas by a single replacement reaction between magnesium metal, free state, and hydrochloric acid. And we generated oxygen gas by decomposing hydrogen peroxide and accelerating that decomposition reaction by using a catalyst, manganese 4 oxide. We tested for the gases using a flame called the flame test.